Bulk stress. When a scuba diver plunges deep into the ocean, the water exerts nearly uniform pressure everywhere on the surface of the diver, and it squeezes him to a slightly smaller volume. So this is different situation compared with the tensile and compressive stress, as we discussed earlier. So in this scenario, the stress now is uniformly applied in all sides or surfaces of our body, that resulting to a deformation, not in length, but deformation in volume. So we use the term bulk stress or volume stress and bulk strain to describe these quantities. So if an object or a body is immersed in a fluid that at rest, so the fluid exerts a force on any part of the object surface. So this force is perpendicular to all sides or to all surfaces. So the force per unit that fluid exerts on the surface is now what we call pressure. And the formula for pressure or bulk stress is the force perpendicular divided by area. Again, it is called pressure if it is in a fluid. So pressure in a fluid increase with depth. So for example, the pressure of the air is about 21% greater at sea level than at any elevation of 1.6 kilometer. So if an immersed object is relatively small, however, we can ignore pressure differences due to depth for the purpose of calculating bulk stress. Hence, we will treat the pressure as having the same value at all points on an immersed object surface. So pressure has the same unit as the stress. Pascal or PSI for English. So it is also common or it is also applied or used in the atmosphere. Okay, so 1 atmosphere or the unit or the symbol for atmosphere is ATM is equal to 1.013 times 10 raised to 5 Pascal. Or in English, 14.7 pound per inch squared or PSI or PSI. So pressure plays the rules of stress in a volume deformation. The corresponding strain in the fractional change in volume, that is the ratio of the volume change to the original volume. So bulk strain is equal to change in volume divided by the original volume. So volume strain is the change in volume per unit volume, like tensile, the change in length, and it is a pure number or a unitless quantity. So when Hooke's law is being obeyed or applied in our situation now, so we can have our bulk modulus. Okay, so the term for the elastic modulus in this scenario is bulk modulus. And the symbol for bulk modulus is letter B, which is equal to the bulk stress over the bulk strain, which is equal to change in pressure divided by change in volume over original length. And it is negative. Don't forget its sign, negative sign. Why negative? Again, when a body is immersed in a fluid, it shrinks. Therefore, the volume change, um, or the volume gets smaller. Our body gets smaller. Therefore, it has a negative change. Okay, so we include this minus sign in this equation because increase of pressure always cause a decrease in volume. So the bulk modulus of a gas, however, depends on the initial pressure PO. Okay, so the reciprocal of the bulk modulus modulus is called compressibility. Denoted as our symbol for compressibility is K. Therefore, compressibility is equal to 1 over B of bulk modulus, or equal to negative change in volume over original volume times the change in pressure. Okay, now, so let's have our example problem. A hydraulic press contains 0.25 cubic meter of oil. Find the decrease in volume of the oil when it is subjected to a pressure increase of 1.610 times 10 raised to 7 positive 7 rather Pascal. The bulk modulus of elasticity is 5.0 times 10 raised to 9 Pascal, and its compressibility is 20 times 10 raised to negative 6 atmosphere raised to negative 1. So our given values are volume of 0.25 cubic meter, change in pressure of 1.6 times 10 raised to 7 Pascal, our bulk modulus of 5.0 times 10 raised to 9 Pascal, and compressibility of 20 times 10 raised to negative 6 ATM. Okay, so we're looking for the decrease in volume. Or change in volume. So to find this one, we will use the formula for bulk modulus, which is change in volume is equal to negative original volume times the change in pressure divided by the bulk modulus. Therefore, is equal to negative 0.25 cubic meter times 1.6 times 10 raised to 7 Pascal over all over 5 times 10 raised to 9 Pascal. Therefore, our change in volume is equal to decrease in volume is negative 8.0 times 10 raised to negative 4 cubic meter, or negative 0.8 liter. You can convert this into liter. So how about if I want to use the value for compressibility, or the value of K, which is 20 times 10 raised to negative 6, or the reciprocal atmospheric value. We can also use that, and simply we will just multiply all the given, which is the change in volume is equal now to negative K, because 1 over B is equal to K, times the original volume times the change in pressure. So equal to negative 20 times 10 raised to negative 6 atmospheric value, negative 1 raised to negative 1 times 0.25 meter cubic times 1.6 times 10 raised to 7 Pascal. Therefore, our change in volume is equal to negative 8.0 times 10 raised to negative 4 cubic meter. Okay, to sum up, our problem, we can now find that we can now say that the decrease in volume is equal to 0.32%. So meaning this ratio can be represented or can be percentage values. You can find that in other problems. Okay, to sum up our back stress, simply back stress when the forces applied at all surfaces or all sides of the body. So if it is in fluid, immersed in fluid, it is called pressure. Okay, so let's try your understanding by solving our next problem.